For these, we're just asked to simplify each thing. It says write the equation of the line in slope-intercept form of the line that passes through the point 2, -5 and is perpendicular to the equation y equals 1/3 x plus 3. So the two things we need are the slope and the y-intercept. Since we're perpendicular, the slope is the opposite reciprocal, which instead of a 1/3, it's going to be a -3/1, which is -3. And then I use a fresh y equals mx plus b. I need to solve for b, so I need an x and a y value, which is why they give me this ordered pair. So I plug the 2 in for x, the -5 in for y, and I simplify. That's going to be a -5 equals a -6 plus b. I add the 6 to each side, and I find out that b equals a +1. So now the equation for this guy is going to be y equals -3x plus 1, and that's it. Number 31, it asked me to factor this completely. And right away, I don't see any greatest common factors, so I'm going to go right to building a bridge. That gives me a -30. So the two numbers that multiply to -30 but add to a 13 are going to be a -2 and a +15. So I'll say 15 and a -2. And now I can't use my shortcut on this one, so I've got to split up the middle term and do factor by grouping. So I've got 3x squared plus 15x minus 2x minus 10. And I group the first two together. I group the second two together. Out of the first two, I can factor out a 3x, which leaves me with an x plus 5. Out of the second two, I can factor out a -2, which leaves me with an x plus 5. So now my two factors are the x plus 5. It's the thing that I had in parentheses. And if I were to take that away, I'd be left with a 3x minus 2. So that's my other factor. Okay? Number 32, it asks us to solve each round to the nearest hundredth if necessary. If we look at the first one, the first thing I always try to do is factoring. So this one I can factor out a 5. Or in this case, since we have an equation, I can divide by the 5. And if I divide each side by 5, I end up with an x squared equals, an x squared minus 6 equals 0. And now from here, I've got a couple options. I can either keep trying factoring, which is not going to work for this one. Let me move this guy off to the side. Or I can do the quadratic formula, or I can complete the square. And really, this one's all set up for completing the square because I'm just going to use my square root property. I add the 6 to each side. That's x squared equals 6. And now I take the square root of each side. Remember, whenever you take the square root of each side of an equation, you have to do plus or minus that answer. And I'm just going to plug this into my calculator, and it gives me a 2.45. Okay, but again, it has to be plus or minus. Whenever we take the square root of each side, it's got to be plus or minus. I get two answers there. For this next one, again, the first thing I try is factoring, so I build a bridge. That's a -12. Two numbers that multiply to -12 but add to a +4 are 6 and a -2. So since I can come up with those two numbers, it means I can solve this by factoring. So I'm going to split up the middle term and factor by grouping. So that's 4x squared plus 6x minus 2x minus 3. And now I factor by grouping and group the first two together, the second two together. Out of the first two, I can factor out a 2x, which leaves me with a 2x plus 3. Out of the second two, I can factor out a -1, which leaves me with a 2x plus 3. And now my two factors are the 2x plus 3, that's the thing that's in the parentheses, and the 2x minus 1. To finish solving my factoring, I have to set each factor equal to 0. And now I just have two little equations to solve, two linear equations. For this first one, I subtract the 3 from each side. Let me extend that screen a little bit. So I get 2x equals a -3. I divide each side by the 2. And I find out that x equals a -3/2. For the second part of this, I add the 1 to each side, which is going to leave me with a 2x equals 1. And now I just have to divide each side by the 2. So I find out that x equals a 1/2. Okay, so my two solutions for this one are the -3/2 and the +1/2. Okay. Number 33, it asked me to sketch the graph of y equals the square root of x plus 1 plus 3 and identify the domain and range. So for this one, let's start with the domain. Remember, what's underneath the square root, the x plus 1, has to be greater than or equal to 0. I can't have a negative under the square root, so I solve this. So I subtract the 1 from each side. So x has to be greater than or equal to 1. So that's my domain, is x such that x is greater than or equal to 1. And that's important to find that first because that'll help me with my xy chart. In other words, that's saying that when I do my xy chart, the smallest x value I can have is a negative 1. Drop to my negative sign here. For anyone who thought I was a crazy person, you were right. So the smallest value I can plug in is a negative 1. And when I do that, it gives me a 3 out for y. But now in terms of my x values, I can only plug in values that are greater than that now. So I plug in something like a 0, and that gives me a 4 out when I plug it into this equation. Okay, maybe I'll plug something like a 1 in next. And for that, I'm going to need my calculator a little bit. So if I plug a 1 in, I get 4.4. If I plug a 2 in, again, I'm going to need my calculator's help for this one. I get a 4.7. If I plug a 3 in, I get a 5. Okay, and so now let's plot all these things. Negative 1, 3 is right here. 1, 4.4 is right here. 2, 4.7 is right here. 3, 5 is right here. So I get this nice gentle curve that increases from left to right. I didn't do a very good job drawing it. Let me try again. There we go. All right. And now when we look at this in terms of our range, again, if I go back to using my lines, vertical line, you can see that my domain starts touching at negative 1 and goes up from there, and that's why it's greater than or equal to the negative 1. But for the range, I do the same thing with a horizontal line. So now I'm going to take my horizontal line and run it up and down. Notice it's touching everywhere up here, but it's not touching down here. So in other words, my y values start at 3 and go up from there. So my range is y such that y is greater than or equal to the positive 3. And that's it. That's my range. For number 34, it says to graph the equation, then identify the following. So the axis of symmetry, the vertex, and really we're going to start off by identifying these things. To get the axis of symmetry and the vertex, we do the same thing. We do the opposite of v over 2a. So that's 8 over 2 times 2. So that's 8 over 4, which is 2. So my axis of symmetry is x equals 2. The vertex, the x value is 2. Remember, that's the same thing, opposite of v over 2a. To find the y value, I have to plug that 2 back in. So I plug it into my equation. So that's 2 squared, which is 4. That's going to give me an 8 minus 16 plus 1. That's a negative 8 plus 1, which is a negative 7. So that's my vertex. In terms of maximum or minimum, since the a value is positive, means this thing opens up, which means I have a minimum value. The y-intercept is right here. It's the constant term, so that's a 1, or you could think of it as the ordered pair 0, 1. And then the solutions are when we take this 2x squared minus 8x plus 1 and set it equal to 0. Okay, and again, you can try doing that by factoring. It doesn't look like this is going to factor, so I'm going to have to do this in terms of my quadratic formula or something like that. So I'm going to do 8 plus or minus the square root of b squared minus 4 times a, which is 2, times c, which is 1, all over 2 times a, which is the 2. Now I just have to simplify this. That's 8 plus or minus the square root of 64 minus 8 all over 4. So that's 8 plus or minus the square root of 56 over 4. And now from here, you just have to estimate those two solutions. So I'm going to plug that into my calculator. 8 plus the square root of 56 divided by 4. So one of my answers is a 3.87. And now my other answer, if I plug this back in one more time with a minus sign instead, I get a 0.13. Okay, so now I'm going to plot this thing. So axis of symmetry at x equals 2. And this is really not a a big enough graph for this, but that's okay. We'll make it work. 2, -7 is going to be down here somewhere. That's your vertex. So it's just off the graph a little bit. It's a minimum, which makes sense. The y-intercept is 0, 1, which is right here. The solutions are 0.3, which is right around in here somewhere, and a 3.87, which is over here somewhere. I can also reflect this point, and so really with just that little bit of information, I can see what my parabola is supposed to look like, and that's it. Number 35, it says to graph the following. For this one, it also says to identify the domain and range again. And so for the graph of this one, really I want to set up an XY chart, but also if you're unsure about the XY chart, it's also got our y-intercept is 2. Remember, that's always this guy right here. And this is exponential decay, which means it's decreasing, so it's getting cut in half each time. So I know that it's going to look like this without doing much work at all. Okay, but again, let's confirm that with an XY chart. I would start with your typical values for X and Y. -2, -1, 0, 1, and 2. Okay, and it might take more guessing than that, but that's what it is. So if I plug the -2 in, 1/2 raised to the -2nd power, I flip it and then square it, so that's a 4. -1, that's going to give me, 4 times 2, which is 8. The -1, that's going to be a 2 to the first, which is 2, times 2, which is 4. When I plug the 0 in, that gives me a 1 times 2, which is 2. When I plug the 1 in, that gives me a 1. When I plug the 2 in, that gives me a 1/4 times 2, which is 1/2. And now if I start to plot these, again, the first one's kind of off the graph a little bit. But we get exactly what I just had graphed before, okay? And we know that it looks like this because it's exponential decay. And so if I break out my my lines again, get a vertical line, that's an x equals line, so that will give me my domain. And so when we look at this in terms of domain, this thing is touching everywhere. No matter where I go, I'm eventually going to touch that function. So the domain is x such that x is all real numbers. And the range, again, I just take a y equals line, a horizontal line, and I drag it across here. Notice it doesn't touch anything down here. It starts touching right here, just above 0, and goes up from there. And notice the line never actually touches 0. So the y values is y such that y is greater than 0. And notice it's not equal to 0. We're never actually going to touch that line. It just gets closer and closer. Okay?